today I would like us to do more of a discussion rather than doing more of writing and examples. Yeah? The reason why I want us to do a discussion is because I've realized that some of you guys have not, what do you call this, have not started studying these things yet. But we'll be dealing hyperbolic functions. It is important for you to understand what hyperbolic functions are made of. If you understand the basic functions, the functions like sine function, cosine function, tan function, and cotangent, secant, and cosecant, this thing will be very nice for you because it has too much of similarities. Né? It has too many similarities. Okay, so hyperbolic functions, let's start here. Okay, come on, okay, it's fine. All right, let me remove this. Okay, sorry about that, guys. Okay, so as I was saying, once you understand the most basic functions, the functions of tan, cos, and everything else, these things are going to be very easy for you. Right? So hyperbolic functions basically are just functions which can be written or however denoted as exponential functions of e to the power of x or e to the negative x, but most of the time it has them both. Né? For instance, if you can look at the first function that we have here, let's look at this function here. This function of this function that we have here, we call this function a sinh function, a cos function. Everything else that you're going to see here is based on the two functions that you see here. So it is important for you guys to understand that these two functions are the most important functions when it comes to hyperbolic function. Yeah? Here they call them hyperbolic sine, hyperbolic cosine and stuff. We call it sinh and cos and tang. That's how we call these particular, these three basic functions. And as we know that cos is a co-function of what? Of sinh. So therefore, if sinh is negative between the two exponential functions, then cos will be what? Will be having a positive. It is important for you to understand the two difference between these two functions. Né? So the only difference that you need to know is what lies between e to the power of x and e to the negative x. It's just a minus and a plus. For sinh, it's a minus. For cos, it's a plus. If you're not fine with that idea, guys, please let me know such that I'm able to come up with something from this one. Eh? Okay. When it comes to sketching of these functions, you do not need to know how to sketch this function. Eh? Another thing is you're going to need to know the range and the domain. The range and the domain, they are basic. They're the most basic range and domain. In this case, they are sketching the graph for sinh, cos, and tang. Yeah? And then they're saying that note that sinh has the domain of the set of real numbers and the range of the set of real numbers, while cos has the domain of real numbers, but its range is different. Now, how is it different? Because the cos function is this pink function. It is going from 1 to infinity because it doesn't have, like the function is not defined after 1. Just beneath 1, this pink function is not defined. And if you can look at this sinh function, it goes from negative infinity to positive infinity on both x and y, because look at the x values, it goes from negative infinity to positive infinity. That's why we're saying the domain of sinh is given as a set of all real numbers, and the range is also a set of all real numbers. So we do not care which number it is continuous on that particular point. Now, when you look at the cosh function, the x values are all defined, but the y values are defined on a specific part. That is the part where we're talking about from 1 until negative, until positive infinity, because just under 1, we do not see anything else, right? Okay, so I want us to look at this function, guys. You remember when you were drawing the function of tan, né? The tan function had something like this, but it was going in this direction, right? Okay, let me try and see if I can sketch. Okay, let me try and see if I can sketch. The tan function or something like this. Okay, guys, please, yeah, please note that this thing is not there. So let me try and get a different color. Okay, and it had asymptotes which are going like this. Okay, so it had asymptotes which are going like this. All right. So we had this function, which was the tan function, and it had what do you call this? Vertical asymptotes. Now with the tanh function, it's going to have horizontal asymptotes. These two asymptotes here, this and that. And you see that the function that we have here is now drawn with respect to x, and the first one was drawn with respect to y. Yeah? So it is very important for you to check the similarities and the differences of this particular thing. But it is not important for you to know how to sketch this function. Yeah? It is not important for you to know how to sketch this function. I believe your lecturer will not tell you to sketch this particular function, yeah, guys. Yeah, so let me just remove this thing. Are we fine with that idea, guys? Are you all okay with the idea? If you're not okay with the idea, please let me know such that I can be able to explain it again. Okay. All right. So to continue, let me take this. Okay. All right. Now you see these two horizontal asymptotes. They're given by the value of y. Now the vertical asymptotes, they were given by the values of x. So it's very important for you to note that. Yeah. Okay. So let us continue, guys. Now we've got, as usual, we do know that basic trigonometric functions, they've got identities. Most of its identities play the same, or they have the same effect also on the hyperbolic functions. For instance, we know that sine, not sinh, sine of a negative angle will always be the negative of that particular thing. It is always going to be the negative of sine whatever angle that was there. But the negative, cos of a negative angle will always be a positive cos with that particular angle. It does, like, this negative does not affect the cos thing, the cos function as a whole. The same thing applies. The sinh of a negative number or of a negative angle will always become negative sinh. And the cos of a negative angle will always be a positive cos. The negative does not affect the function in any way whatsoever. Yeah? It is very important for you to know that, guys. Okay. So the second thing is, do you remember the identity that said that sine squared plus cos squared is equals to 1? In this case, it is very important for you to note that it's going to be cos squared minus sinh squared is always going to be equals to 1. And I don't know if it's proven. Let me see. Oh, I think it's proven somewhere here. Yeah, it's proven. Now, it is very important for you to know how to prove this, guys. I know when it comes to Mr. Zweni likes to bring such questions up. So it is very advantageous for you guys to be able to prove these things. Yeah? It is very advantageous for you to know how to prove these things. But it's very simple, because as you can see here, you're just going to change this cos into E to the x minus e to the negative x divided by 2, and then square the whole thing, minus whatever that is there. Then you are going to show that the left-hand side is equal to the right-hand side by just substituting these two, right? Because it's cosh squared minus sinh squared is equal to 1. Ne? Now, I'm going to show you the proof. It's in the next page. And also, we do know this, the existence of this particular identity. Now, take note of something, guys. Take note of something. With these ones, we only got these identities. It is very important for you to note that, guys. We only got these identities. These are the most important identities that we have for hyperbolic functions. Please do note that. Ne? Please. But so far, guys, do you have any questions before we start looking at the proofs and stuff like that?
No. No.
Okay, thank you.
What? I didn't ask them. I am.
Okay, I can see that. Okay, let me just do this. Okay. All right. For us to continue, let us look at some of the proofs that we are going to have here. But guys, it is important, guys. Like, you do not need to cram, you just need to understand. Guys. That's the only thing I'm trying to show you here. Man. Okay. In this case, guys, there is some other identities which I'm going to introduce to you as we go and as we write these things. Yeah? But for now, let us just stick to these things, because now we are just having a discussion more than just having that thing of us coming here and then having a session where we just do questions. Now it's about time for us to understand the theory before we can be able to solve these questions. Yeah? Okay. So these identities are very important. I'm going to add a few more identities because these are only 6. I want to add 4 more. And those 4 more, you know them, guys. You know them. Yeah, you just know them. Let's just not dwell too much on that one. Okay. So let us move, guys. Okay. Now let us look at the first proof. They say that prove that cosh squared x minus sinh squared x is equal to 1. That is the first proof. And I said to you, it is important for you to know and understand what represents sinh and what represents cosh. Then once you know that, you're going to substitute it here. Then square whatever that represents cosh minus whatever that represents sinh. And then after that, we're going to use BODMAS, né? Because it says brackets first and what, but whatever that is in the bracket, it is already a simplified form. So we are going to move to the second part of BODMAS, which is orders. Orders represent the squares, the square roots, all of those things. Né? Now what's going to happen is we're going to square the numerator and square the denominator. By squaring the numerator, we're going to get e to the 2x plus 2 plus e to the negative 2x. Then divided by squaring of what? The denominator, which is 4. Then minus, this minus is still there. Do you see it, guys? This minus just came down here. And then we are going to do the same thing also for this one. Then get this. Né? After that, we are going to carefully multiply each and every term of the second fraction with this negative. So it's going to become e to the 2x minus e to the 2x. 2 plus 2, because negative times negative, it's a positive. E to the negative 2x minus e to the negative 2x, which means, let me take this, let me take a pen, which means that this, and this will cancel out. Then we're going to be left with what? 2 plus 2, because this negative times this negative will give us a positive. 2 plus 2 will become a 4. But since they've got the same denominator, we'll just write the denominator here. Then 4 over 4 is just equals to 1. Then this proof, guys, is something which I can say that you understand. But if you don't understand, please let me know. And then, yeah. I will help you with that one. So guys, I will find the idea.
Yes, sir.
Okay. No, thank you very much, man. Thank you very much. Okay. So the second part, they said that prove that 1 minus tanh squared x is equals to. Now this one, guys, we do not know the exact name of this one, but we call it the secant hyperbolic function. Yeah. So what they did was, we took whatever that we proved here, yeah, because we know that the secant function is related to cos, right? It's related to cos. So what we did was we took whatever that we proved there at the top, the first part, that cos squared minus sin squared is equals to 1. Then after we divided each and every term by what? By cos squared x, because we know that 1 over cos is sec, and the same thing applies for sec hyperbolic function. And then it's just going to be 1 over what? Cos. Yeah? So what they did was we divided each and every term here with cos squared. Then we're going to get 1. Divide this by cos squared, you get sin squared divided by cos squared. Then here we're going to have 1 minus cos squared. Yeah? Okay, guys, my internet connection is very weak. It's very weak. Okay. So after doing that, we are going to realize, now let's go back to something. I want to show you the definition of tanh is sinh over cos, right? So therefore, rather than writing sinh over cos, we just wrote tanh squared x. And then, as I said, that hyperbolic function squared. Yeah?
Yeah.
Okay. Okay. Now, guys, another thing that you need to understand about this, yeah? Again, we did identities. We started off by definition of hyperbolic functions. We did identities. Now we need to understand another important aspect of this thing called the derivatives. Guys, the derivatives, it does not change. It is very important for you guys to understand that part. It does not change. Yeah? Let us look at something.
Yes,
It says that the derivative. Okay, another thing that you need to know, guys, is when it comes to derivatives, we must go back to the original functions, yeah? And look at what is the derivative of sine, its cos, the derivative of other. It does not change. It's just that now we just introduce the h to show that this is hyperbolic function. Yeah? So now the derivative of sinh will always be cos. And this is the proof of how this thing happens. But now the nicest part about it is we know that if we are given e to the power of x, né, the derivative of this will always be what? E to the power of x. It does not change. I'm running out of time.
yeah.
Come on. Okay. So now what happens is if I get a negative here, I'm going to get a negative here as well. Hence, this thing changed from e to the x minus e to the negative x into e to the x plus e to the negative x, because the derivative of e to the negative x will be equal to negative e to the negative x. You see that, guys? Ne? I really hope that you see that. But we are going to do this nicely, guys. Here we are just having a discussion about this particular thing.
Yes, the Punisher.
Okay. So now I want you guys, it is very important for you to know how to prove all of these things, because yeah, the lecturer is going to require you to know how to prove such things. More especially if it happens that you might write your sit down exam. So therefore it is safer for you to do that. But it is not confirmed if whether you're going to write your sit down exam or not. So for safety purposes, I would tell you to be able to do that. Yeah. Okay. Just know how to prove this, prove that, prove this. It is using the same way as what we are doing with the original. Yeah? Okay. So now inverse functions, they also work the same. The thing is, when it comes to hyperbolic functions, guys, hyperbolic functions just show you the same thing as the original trigonometric functions, because like most of the things that trigonometric function does, they also do it as a hyperbolic function. So it is very important for you to understand the trigonometric functions for you to be able to understand the hyperbolic functions. Yeah? It is very important for you to do that. And you must also be able to know that these things can be rewritten as logarithms. So it is very important for you guys to also be able to do that. Yeah? Okay, let's check. I think somebody wrote something in the chat. Okay. Can you please tell our lecturer to upload the data assessment plan so that we know the days we will be having an assessment? Okay, with the question that you're asking here, the dangers that we are having is that sometimes the sessions might be cancelled. Sometimes, like a lot of things happen. Like for instance, last week we were supposed to write on a Friday, but it was cancelled. Then we had to have our session. And therefore, we had a problem with making a quiz, because the quiz that we wanted to make was to make you be ready for the test that you are writing on Monday. So since on Monday you were writing, we had to have a session such that we are able to try to make you be ready for the test. And most of you guys did very well for the test, so big ups to you, big ups to you. Keep on making that hard time. Okay. Okay, so is there any other questions, guys, that you have? Let me check. Okay.
There's no question.
Okay, so as I said, all right, before, let me go back here. Ne? The nice thing is that Mr. Zedi does not like to complicate these things, guys. Just know how to prove these things, just know its derivatives, just know its oh yeah, the next thing you need to know how to show that this is equals to that. It is very important, guys. It is very, very much important. And what is going to be the biggest problem for you? Okay, what I think might be the biggest problem for you guys is how are you going to show the whole thing it is equals to that? Yeah? How are you going to show that is not the biggest problem? Because if you can go back here, it shows that y is equals to arcsine x, but you can change that and say that since y is equals to x, then therefore you're just going to find what? The derivative of this particular thing with respect to x. I mean, with respect to y, because yeah, this thing is written with respect to y. Then if you do that, you're going to see that this side, you're going to have what? What do you call this? But you don't need to do that as yet. Okay, this one I'm going to make a proof of it in the next session. Let me not spoil the fun for us. Let me not spoil the fun for us, because it's a beautiful way for us to prove this. It's a beautiful way for us to prove this. But I can give you an idea. The idea that I'm going to give you, it's going to be very simple. Now we can denote this as e to the power of y. And then we're going to have this is sine minus e. Okay, that was terrible. That was terrible. That was terrible. Okay, let me remove this. Okay, so we're gonna have e to the power of y minus e to the negative y. Ne? This will be divided by 2. And then we're saying that this must be equals to x. Ne? This must be equal to x. Okay, let me see. I see a question here. Can there be at least guarantee that we will be told a week before we can write an assessment that we prepare? Oh yes. I'll make sure that you are told in due time that you are going to be writing a certain thing. Yeah, it's not going to be fair that you guys are going to get schoolwork and you're not even sure on when it is. Yeah, all of those things. It is very important for me to be very honest with you guys from the whole thing. But I'll make sure that you are going to know, maybe if possible, 2 weeks before you write that thing. But if it's not possible, a week is more than enough for you to know that you're going to be writing a particular thing. I hope I've answered the question.
Okay.
Okay, so to continue with this, I'm going to multiply by 2 on both sides. Then have e to the power of y minus e to the negative y. Okay, this thing is is equals to 2x. Ne? Then transpose the 2, have e to the y minus e to the negative y minus 2x is equals to 0. Ne?
And
Okay, so I'm going to have this, then put it there and say e. Okay, that was terrible. Oh, I'm left with 2 minutes. Okay. Okay, guys, let me take the register for those who attended. Let me just take the register first. Okay. All right. Screenshot.
KB.
Okay. All right, so what is going to happen is now, since I've got something like this, I'm going to have e. Come on. Why is my handwriting so terrible? I'm going to have e. Okay, please give me a minute, guys. Hey, Chief.
Dá-me a nossa goliça.
Sorry about that, guys. Sorry about that, guys. As I was saying, I'm going to have e to the y minus 2x minus e to the negative y is equals to 0. Yeah? So I'm going to have something like this. Okay? So from here, what you're going to do is on both sides, you're going to multiply by e to the y, to the positive y. And also on this side, the whole thing, you're just going to multiply by e to the power of y. Okay? So for now, just leave it here, and then you continue with that idea. And then we're going to do its proof very nicely on Monday. So since we have got less than a minute, let us just return on for the second part of this session, such that we can complete discussing the slides. Then we'll end our session nicely.
Sure.